Hey, ScannerDanner here with my friend Pete Latour. I gotta say hi, Pete. The last guy said you look like you're losing weight. I said Pete's been boxing again. Former Golden Glove champ right here. Don't want to mess with Pete. Right? Make sure you pay your bills. All you customers out there, pay your bills. Pete might beat you up if you don't. Caleb Danner behind the camera. Thank you, cameraman Caleb, for being here with us today. This is our third AC check for the day, and the first two were empty. Let's see if we can get 3 for 3, huh? Wow, symptoms just, their complaint, Pete, just no air, yes? Looks like compressor's new.
Right, that was all changed. Water pump compressor, and that was about...
when was that changed?
About a year ago.
A year ago?
Problem, yeah.
Okay.
It was growling and grinding.
Gotcha. What do we got? Oh, 3 for 3. Wait, no. Nope, this one has some refrigerant in it. Where is my low pressure Schrader at? Okay, so what's the temperature outside today, Pete? Right now, what do you think, about 70 something? It's hot in the sun, but...
Sun's hot, yeah.
So, looking at our pressures here, one pressure with the system off, we'll look at our low pressure gauge because it's easier to use. So that's showing us about 68 PSI, and that's a little bit low for the temperature outside today. I would expect that to be more around 75. Our refrigerant that's in here is R134A, which is really close to the Fahrenheit scale as far as temperature and pressure goes. So if it's 75 degrees outside, we should have about 75 pounds of rest pressure. Although sitting here in the shade, it is pretty cool in the shade, isn't it? It's possible that could be good as far as our temperature to pressure relationship. What that tells me is there should be enough refrigerant in here to start this AC compressor clutch, which is what I'm gonna do. All right, I'm gonna start this up. Nice squeaky belt for our video. Gotta love that. Wow. All right, so this is low on refrigerant. Right off the bat, what we're looking at, you see that low side gauge is actually going into a vacuum. There could be a restriction too. Let's watch the high side too. High side went to 150. I don't like the way, how slow that's recovering there. This could be an expansion valve problem, especially how much it's going into a vacuum. So for me, the only real way to know our charge level on this would be to pull the refrigerant out, measure it. Hey, Pete. We're actually going to be probably done with this one. I want you to watch this compressor cycle. I think this could be low on charge, but I don't like the recovery rate of this low side. If this was just low on charge, that would be coming back a lot faster. Watch what it does when the compressor kicks back on. I think we have a restriction in this system. Like the expansion valve is faulty, the H block they call it. But watch what it does. That recovery is ridiculously slow. There's no way it should be doing that. This isn't just low on charge. See it go into a vacuum on the low side? Like it was zero. I mean, at one point I saw it pull down even lower. High side went up to 150. So there should be enough refrigerant in there that this should at least be recovering quickly and then cycling again, in my opinion. Now, the only way for me to know that for sure with 100% certainty would be to recover all the refrigerant out of here, measure what's in there, and then put it back in, and then be able to finish my diagnosis. I can't do that. We don't have a recovery machine. We're kind of screwed. Do we want to put a can of refrigerant in it and see how it reacts? I would say no, because we might be overcharging it. You know what I mean? I guess, what are our options? You have a can of refrigerant? I don't think it's the answer. We can try it just because for video reasons I can show that putting refrigerant in this is not going to fix this. My opinion is it's not. We have a restriction in this system, and I would probably... Well, I mean, that
locked up and the water pump.
The compressor was locked up on this, but it wasn't internally destroyed, was it?
No.
It was the clutch itself, the clutch bearing. So that shouldn't pump debris in the system. But here's the other problem, right? It may not be a plugged expansion valve. It could be a plugged up condenser. It could be a plugged up dryer. This to me says restriction. You said he had a can of refrigerant. Was that this vehicle or is that another one?
Another one up there.
Do you have a can tap that I can adapt to this?
Yeah.
I'm not convinced that this is a low charge. This to me looks like something more than that.
Tank 1 sensor.
So this is a full can, Pete?
Yeah.
Okay. I don't think this is going to fix this. And what I was telling Pete, without a recovery machine, our recovery machine here is down at the moment. Our hands are tied, man. I really want to know how much refrigerant's in this. This could be low on charge, but I'm not seeing it. I'm not seeing it. This is not reacting. It's not recovering like it should. I'm still at 10 pounds of pressure on the low side, about 70 on the high. This isn't reacting like it should be. That should have recovered. This is suggesting to me a restriction in this system. The only way that I can prove it to you guys right now is to add a little bit of refrigerant and see the reaction. Now, I could be wrong. Maybe it is low on charge and temperatures are making that expansion valve stay closed. I don't think so. I need to be careful about how I'm adding to this. Very important that our gauges, let me hang this up here, Caleb. Very important when we're adding refrigerant. Safety, make sure your high side is closed, okay? That valve is closed. We're gonna add to the low side. The other concern is if you follow the blue hose, it goes right to the back of the compressor. And so we wanna be careful that we don't slug this compressor with liquid refrigerant. And right now, if I add like this with the can up, I'm adding as a vapor. If I turn it upside down, I'm adding as a liquid. Now we do have 6 foot of hose before it gets there, but these are things we need to consider when we're adding refrigerant. Right now that's closed. I'm gonna pierce the can. We'll add as a vapor just because of where this is. That is now open. Adding to the low side. That compressor should kick back on. I'll be surprised if this is just low on refrigerant. And that's what we want, but look how high that high side pressure got. That was like 225 on that one. We're gonna watch that high side pressure. There's 250. You see how much better it's cycling. I could be wrong. This could have just been low on charge and reacted differently than what I've seen. I'm okay with 250 on the high. Next. Nope, 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 nope. Did you see how high that high side pressure got? This is not low on charge. And look at the low side recovery rate again. So my high side pressures, my suspicions were right, Pete. We have a restriction in this system. And I used about half of that can. So you at least have half of it for another car. Watch our high side pressures now. It is not hot enough to be the temperatures, hitting 300 PSI on the high side would be a 90+ degree day where it's running constantly. This has a clutch fan So, you know, airflow is an issue too when you see high side pressures, but combine that with, number one, the fan is working fine. I got good airflow. To number two, looking at this low side gauge and how slowly this is recovering. Watch what it does when it kicks back on again. Watch what this high side gauge does. And again, watch your low side. We have a restriction, Pete. Where is our restriction? When that compressor was replaced, it was the clutch bearing that went, correct? It was not the compressor itself. Okay. See, if the compressor itself imploded, then what that does is it ends up pumping pieces through the whole system. And where the suspicions are for that, the first place you would check is the condenser, because that's where it goes next. It goes from the compressor to the condenser next, and condenser is highly suspect. Yeah, see, we hit like 275 on that, and this again went down into a 0 PSI, almost into a vacuum. I think there's your condenser fan. Yeah, there's no way. Restriction, Pete. Now, the problem with this now is, where is our restriction? There's ways we can find restrictions, and that would be based on temperature. What we can do is, let's say, for example, down here where my hands are, Caleb, let's just say, for example, you had a restriction right here. No, we don't, but I'm just using this as a visual aid. So what you do is, you'd really just by feel, you would put your hands on this line, and let's say this was it really wouldn't matter what line it was. If that was your restriction, this would be warm to touch here, and it would be cold to touch on this side, and that's how you could locate a restriction. Now, the problem with a temperature measurement for us right now is I can't get this compressor to run for any period of time. It's pulling into a vacuum right off the bat, and to be honest with you, I'm really not sure where to guide you. I think the way that I would sell this job, I'd probably sell a condenser and an expansion valve. That's where I'd take that back. I'd say condenser, we'd put a new dryer in it, and also change the expansion valve, which is back here on this Chrysler. That would be the direction. As I'm pointing that out, there is a pressure sensor right here. Is that a sensor or a switch? Let's take a look. It's 2 wires. That's going to be a switch, so that's not going to help me. What I was thinking is, I could get a reading on the scan tool right there and compare that reading to what I have at the compressor, which is here. Let me just eyeball my plumbing here real quick. Yeah, that's really not going to help me. All right, so direction of flow, it goes from compressor, it comes out this line, goes into the condenser, runs through the condenser fins on this line, comes out on this line. So this is high pressure gas, comes out as a high pressure liquid on its way. That's what I'm measuring here. So I have high pressures here. I'm just thinking about how this is working here. A very high pressure here. That's the discharge of the condenser. So that means this condenser is not plugged. If the condenser was plugged, I would have low pressure in this location. So here, bear with me. Again, plumbing is key. High pressure gas comes here into my condenser. If my condenser was restricted based on where this high pressure line is, which is the discharge of the condenser, that's telling me my condenser is a non-issue. All right, so from there, we got high pressure here. High pressure liquid goes into a receiver dryer. This receiver dryer ensures that only liquid refrigerant gets to our expansion valve. This is still high pressure liquid, comes here, and it runs under the air cleaner box, and then comes up where my left finger is here, and it goes into our thermal expansion valve, which is this block right here where my finger is. So high pressure comes into our expansion valve, which is right here, and then that's what takes the high pressure gas and turns it into, or sorry, high pressure liquid, turns it into a low pressure liquid, and then comes out on this side as a low pressure vapor after it leaves the evaporator, and then on its way back to the compressor. What would be nice in troubleshooting this is if I had service ports in various locations, then I could do more pinpoint testing. But I'm glad I talked to you guys through this, because I believe now that the condenser is not an issue, and I changed my mind as far as my direction and where I would go with this vehicle. I really think that what I would do is I'd put an expansion valve in this as a starting point. Could we have a plugged up evap core? Yeah, we could. But I think as a starting point, I'd put the expansion valve in this. In fact, that's what I'm going to tell Pete to do. And there was a way that we could check these expansion valves, but not when they're stuck like that. But the theory was, if you cool it and heat it, we can make it change its opening, and we can make it change pressures. I don't have anything to do that. Pete, my call on this truck, I hate to be a parts changer, but that's what I want to do. I want to put an expansion valve in this as a starting point. They're not expensive, and it's right here where you don't have to rip the whole dash apart. Okay? This is a 2000 Dodge Durango 5.9. Yeah. In the meantime, we're gonna have to get this recovery machine taken care of so we can pull this refrigerant out, change that expansion valve, and I'll bring you guys back online, or back up to speed when we change that valve. I have another concern before we do this job, and we're still gonna do the expansion valve, but some of these compressors, what parts manufacturers are doing is they're supplying a full system charge of oil in the compressor. I don't know why they do that. It's ridiculous. They shouldn't do it. There is a possibility that this compressor was put on with too much oil. So in other words, if you're changing a compressor because a clutch pulley went bad, right, which is what was done, there's no reason to put really any oil in it. Maybe a half an ounce to an ounce at most of refrigerant that you should put, or not refrigerant, of refrigerant oil that you should put in this system. If that compressor came with a full 8 ounces, and that 8 ounces of oil was added to this system, it's overcharged with oil, which can add to what we have going on here. When I took my gauge off, all of this oil on the ground right here came out of my high side hose. To me, it was extremely excessive, the amount of oil that came out of this line. Now, granted, this should have been recovered, but recovery machine is being worked on. This was good evidence for me that this thing was overcharged of oil, and that's going to contribute to our issue. Expansion valve, and what I told Pete we need to do, pull the lines off the compressor. I'll take an air nozzle and we'll blow air into one side and blow all the oil that we can out of this system, and then not put any more oil in it. I've run into this before. I worked for Pep Boys years ago. The car was on its 3rd compressor when it got to me, and every tech, if you want to call them techs that were working on it, kept putting new compressors on, and they kept putting a full system charge of oil back in it. Each new compressor was coming with a full system charge of oil. You can't do that. You're supposed to drain the oil out of the old compressor, measure it, and that's what you put back in the system. And if you guys have done air conditioning work, you'll know that you get almost no oil out of a compressor. So how much oil should you be adding to a system when you change a compressor? An ounce at most. I'm concerned about that with this thing. We'll see how this goes. I'm not sure how much of the recovery part we're going to see because the machine's being worked on, and I might not be here. I will get you an after, let you guys know what we come up with. So just adding this to our Durango here and what we're calling, which is an overcharge of oil. When I blew the air out of this Mitsubishi, separate video, separate car, you guys will see this at some point in time. Look at all of this oil. The camera's probably not going to show it because I wiped a lot of it up, but all of this that looks clean and shiny, oil everywhere from this high side line. And that was from that Durango. There is no freaking way we should have that much oil in my high side line, and it all came from that Durango. And I am absolutely convinced that that vehicle was put together with too much oil in that system. We're still going to change the H valve, the expansion block, the expansion valve, whatever you want to call it. It's an H block, H valve they call it. We're going to change that, but that system, too much oil. I am absolutely convinced that that is what is wrong with our Durango. Okay, just real quick, I wanted to show my suspicions on this Durango were too much oil, and I had Pete do the recovery and everything, and he's got the stuff apart. He's got the H block off in the back, and actually let's get a shot of that real quick, Caleb. And I apologize for the mic change here, guys. We're not using an external mic anymore, but this is your expansion valve right here. So that sits in the dash, right? And that's your restriction. Controls the low side port, and it's based on the low and high side pressures. But just how much oil came out of my line, I'm going to show you guys how I do this when I have a vehicle that's been overcharged of oil. It's disconnected from the compressor, so we're going to go high side line first. That goes down into the condenser, which is up front up here, and then it's going to come out this line, which is this dryer. Actually, that's going to shoot us in the face here, Caleb. I'm glad I mentioned that to you. Maybe we go the opposite direction. I'll do that. I'll go air in this hole here, and what we're going to do is put air from here, and we'll go through the condenser, and then it's going to come out right here. Okay, so we're going to see how much oil is going to run all over this compressor when I do this. Okay, nothing excessive, I'm surprised. That's what you do though. If you get somebody that's overcharged the system with oil, separate some lines, take it apart. I just blew through the condenser, and the fact that nothing came out of there tells me that my suspicions were wrong about the overcharge of oil. Let's blow this line out too, since we're apart. And this is gonna come out now back down that way. Nothing doing there. And then one more is we'll blow this evap core out right here. This will kind of help with our restriction too in the back. Let's see. You're not going to see this part, Caleb. I don't like that. It just feels like the restriction is in our evap. Okay, we're good. Yeah. I was wrong. This was not overcharged with oil. That's the method you use to make sure. It's all opened up to air anyway. And H block restriction. So what you could do on some of these, you can actually heat and cool this area here, and that sun's not going to help you. It was all right. How about like that? So you see the stem inside of there, and what you do is like heat and cool this chamber, and then see if the valve moves up and down, but I'm not even going to worry about that. This is the part we're going to change, and what I'll do for you guys is once we get this new part on, we'll recharge the system, and then I'll get us our after pressure readings. Okay guys, we are back on the Durango. I was mistaken again about too much of an oil charge in this thing. I believe it's been a day or two and I was working on multiple cars, but I believe I just showed you the footage of me blowing the lines out and not having excessive oil here, so was one of my concerns. I would have liked to have shown some better thermal expansion valve tests where we heat it and cool it and look for reactions. Just didn't have what I needed to do it. Made the call on the expansion valve. I have to be honest with you guys, it's a little bit of a guess, but just based on the fact that when the compressor was replaced, that it wasn't an internal implosion. It didn't explode inside and pump stuff through the system. This compressor was replaced because the clutch bearing went bad. That was why. So in light of that, I knew we had some type of restriction in the system, and the most likely location was that thermal expansion valve, and it being a very easy one to replace, that's what was done. The expansion valve was replaced and the system was refilled with the proper charge. Now we're back and we want to see what our pressures do. So all you missed off camera is I disconnected my gauges. We're a little bit warmer today, and my rest pressures are higher than what you would have seen the other day. It's a lot more humid. It's a lot hotter out. We have about 95 pounds of rest pressure at this point in time. So Caleb, you focus on the gauges and I'm going to start this truck up. That's what we want to see. And you not knowing anything about air conditioning work, Caleb, you remember how this low side was going way down to 0 and at times even into a vacuum. That's what we want to see. What I don't like right now is how high my low side is, but we just started it. Let's give it a chance to stabilize. Close the doors too. I'm going to raise the RPM a little bit. You stay focused on that. Awesome. So we're going to call that one a fix. You know, some of you are thinking, well, you got lucky, Danner, on that one. I might agree with you on that. I don't know if I'd call it luck as far as making the right call on where the restriction was in this system, but maybe an educated guess. But it was a relatively inexpensive fix. Restricted, I would say, stuck closed thermal expansion valve. And if this was one of those systems where we could have kept the compressor running for a longer period of time, we could have done the pressure and temperature test that I had mentioned just by feel and locate restriction that way, either using a temp gun or by feel, or in today's day and age, there's a lot of you guys that are using thermal imaging cameras too, which can identify restrictions as well. So yeah, thumbs up on that one. Calling this a fix. That's money in the bank. Catch you guys next time. I almost forgot, because I've shown this one other time, but I want to show it to you guys again. Just a real quick way to make sure you get all of the refrigerant, or at least most of the refrigerant, out of your gauges before you take them off. Right now we have about 175 or so on the high, about 40 on the low. So here's what we do. Step one, these valves are closed, okay? Open your service port, or really you're closing it. We're opening our valve, but that's closing the service port on the high side. So now this high side pressure that's trapped in here is isolated to this high side line. I'm no longer attached to the system. Another important piece, you want to make sure that your center hose has a check valve in it. So I'm relying on this check valve in my center hose. Next step I'm going to do, open this service port. When I open this service port, I just sent that high pressure that was in my red hose down into my yellow hose. So now it's sitting here. And now what I want to do is open my low side valve. And so what I'm essentially doing, you getting this too? What I'm essentially doing is I'm pulling out the high pressure that was in my red hose and now in my yellow hose with my blue valve open. I'm now pulling it out of both of those. And now I have 40 and 40 on my two gauges. Before I do anything else, I'm going to rev this up. Still pulling pressures out of here. Leaving this open. Now up here, Caleb, opening this, which is closing that Schrader. Okay, good. And now look at my gauges. I'm gonna shut it off, stay there. Now basically what I've done is I just have 20 pounds of rest pressure in both. I've essentially pulled all of the refrigerant out of my gauges. There's a little bit left over, but it's a good tip for you guys that don't have recovery machines and ways to pull refrigerant out. It's a good way to get rid of that refrigerant that's in your gauges. It also is a way that I think I've measured them before with a recovery machine. It can be as much as an ounce or two of refrigerant that you're leaving in your gauges, but if you do it this way, you'll be able to get it all out. Now we're really done this time. Guys, thanks for joining me. I'll catch you next time.